Object-oriented programming, or OOP, is a paradigm that organizes software design around data, or objects, rather than functions and logic. In Kotlin, this approach is not just supported, it's celebrated. Kotlin's design makes it an exceptional choice for object-oriented development, blending modern programming practices with a concise syntax that enhances productivity. Let's dive into the fundamentals. In Kotlin, defining a class is straightforward. Imagine creating a class called car. You can define properties like color and model and methods like drive or stop. Instantiation is just as simple. You create an object of car using the car constructor, and suddenly you have a unique instance of your class ready to roll. Accessing class members is intuitive. You can easily retrieve or modify properties and call methods using the dot notation. For example, if you have a myCar object, you can set its color with mycar.color equals red and invoke its drive method with mycar.drive. This clarity is one of the many benefits Kotlin brings to OOP. Now, let's talk about inheritance. This concept allows you to create new classes based on existing ones, extending their functionality without rewriting code. For instance, you could create a sports car class that inherits from car. By overriding methods, you can customize behaviors. Perhaps the drive method in sports car accelerates faster than in car. This flexibility is a cornerstone of OOP. Abstract classes and interfaces further enhance this capability. An abstract class can provide a base with common functionality while leaving specific implementations to subclasses. Interfaces, on the other hand, define a contract that classes can implement, promoting a clean separation of concerns. This means you can design systems that are both modular and scalable. Encapsulation is another critical aspect of OOP. It's all about protecting your data. By using private and public modifiers, you control access to class members. For example, you might want to keep certain properties private to prevent external modification, exposing only what's necessary through public methods. This not only safeguards your data, but also promotes code reusability and maintainability. Let's put this all together with a practical example. Imagine building a simple application for a car rental service. You could create a car class, a customer class, and a rental class. The car class could inherit from a vehicle abstract class, implementing methods specific to cars. The customer class could manage customer details, while the rental class could handle the logic of renting cars. By demonstrating inheritance, polymorphism, and encapsulation, you create a robust application that's easy to maintain and extend. When designing your object-oriented systems in Kotlin, remember a few tips. Keep your classes focused on a single responsibility, favor composition over inheritance when appropriate, and always think about how encapsulation can enhance your design. By following these principles, you'll harness the true power of Kotlin's object-oriented magic, creating applications that are not only functional, but also elegant and maintainable.